So this is a second example we're going to look at. This time we're going to find a length. So we're not going to find an angle using tangents to a circle. We're going to find a length, okay? So this time we actually have two tangents if you look. We've got BC here as a tangent, see? And then AB is a tangent as well. We've been given some lengths. So we've got 8 centimetres and 6 centimetres. And the question says, find the length of OB. Now OB here is a dotted line, okay? So the first thing we have to establish is where is the right angle, right? So this is a radius. This is also a radius, so that means that we're going to have a right angle here, where it intersects with the tangent, and we're going to have a right angle here, where the radius and the tangent meet. Now, I'm going to use the top triangle. There's actually two right angle triangles if you look here, see? There's one at the bottom and one at the top. So I'm going to use the top one, just because there are numbers on the top one, right? That's the only reason. I could use the bottom one. This side is 8 as well, because these are equal. And the radiuses, or the radii, sorry, are also equal, so that will be 6 as well. Because the numbers are here, it's nice and convenient, so I'm just going to use that. Now, a strategy that I found works really well when doing these questions is, if we can kind of extract the right angle triangle, it makes it a little bit easier for ourselves, okay? So, we've got right angle triangle here like that. Okay, so I've just taken that triangle and I've drawn it again over here, and this is our side OB that we're looking for. Alright, so we're going to use Pythagoras' theorem. This is a hypotenuse because it's opposite the right angle. So OB squared is going to be equal to 8 squared plus 6 squared. So OB squared, if we add that up, that's 100. I'm sure you can see where this is going. So OB is 10 centimetres. So remember, what I've done is, I have used the fact that a radius and a tangent intersect at right angles all the time to prove that there's a right angle here, which has then allowed me to use Pythagoras' theorem to figure out the length of OB. Okay? So without knowing that a tangent and a radius meet at right angles, I wouldn't be able to get that, and then I wouldn't be able to use Pythagoras' theorem because he only works for right angled triangles. Alright? So just to go through it one more time. We've used tangent and radius intersect at right angles. So that's a right angled triangle here. And then we've got one here. We're going to ignore this one. We don't really need it. It's an exact copy of this. This is a line of symmetry. But we are asked for the length of OB. So what I've recommended we do is we take our diagram out of this whole situation to make it a little bit more simpler to understand what we're going to do. I'm now going to use Pythagoras' theorem. I've got the hypotenuse. Other sides are 6 and 8. That's one of the Pythagorean triples. So if I work that out, 8 squared plus 6 squared is 100. And then the square root of that is 10. Now I have taken lots of shortcuts with this little Pythagoras step. If you go back and look at the Pythagoras video, you will see how to do Pythagoras' theorem in a bit more detail. But I've taken it a little bit quicker, just to kind of abbreviate this video a little bit if I can. Okay, so I hope you understood that. Remember, you can pause, rewind and do all that stuff to go over it yourself. Okay, but that's it.